have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe.
In the vast expanse of our solar system, where cosmic wonders have captivated our imaginations for centuries, one celestial giant has been a source of awe and fascination like no other: Saturn. With its stunning rings and enigmatic beauty, Saturn has always been a beacon of stability in the ever-changing cosmos. But what if we told you that this beloved ringed planet, the jewel of our night sky, is undergoing a transformation that has left scientists baffled and concerned? What could be happening to Saturn, and why is it causing alarm among the scientific community? In this exclusive, groundbreaking exploration, we'll unravel the mysteries surrounding Saturn's perplexing metamorphosis. So, join us as we journey through the cosmos to understand the forces at play that are leaving scientists completely stumped. Essentially, Saturn is changing, and it's not good. The early discovery of planet Saturn. Saturn, the mesmerizing giant of our solar system, has captivated scientists and stargazers alike since its discovery. It holds a special place in our cosmic curiosity. While it hasn't been graced by human footsteps like Mars, it's a favorite of astronomers. Interestingly, humans have gathered a wealth of knowledge about this ringed wonder. Its mysteries, spanning from temperature variations to its magnetic field and lunar companions, never fail to astound us. As the sixth planet from the Sun and second largest in our celestial neighbor, Saturn holds a prominent position in our galactic neighborhood. The pioneering astronomer Galileo first turned his telescope toward Saturn in 1610. In those early observations, he perceived what appeared to be ears or arms on either side, misinterpreting the iconic rings that encircle the planet. Galileo's telescope wasn't quite up to the task, revealing only a fraction of Saturn's true glory. However, his efforts paved the way for the wealth of understanding we possess today. Similarly, in 1659, a Dutch astronomer named Christian Huygens, armed with a more powerful telescope, cast his gaze upon Saturn. To his amazement, he unveiled the intricate ring system encircling the planet. Not stopping there, Huygens also laid eyes on Titan, Saturn's largest moon, adding to the growing celestial understanding. Following this in 1675, another astronomer, Cassini, made a significant discovery, finding a gap amidst Saturn's rings, now named the Cassini division, marking a clear partition. As time unfolded, the exploration of Saturn continued, offering fresh revelations. Decades and centuries saw new layers of knowledge unveil, enhancing our comprehension of this extraordinary planet and leaving a rich legacy of discoveries for generations to come. Saturn, the second largest planet. Meanwhile, in 1979, the Pioneer 11 spacecraft gifted humanity with the first close-up snapshots of Saturn, launching our quest to decipher the secrets of this celestial behemoth. However, it wasn't until the arrival of the Cassini mission in 2004 that scientists could truly unveil the astounding marvels of this ringed world. As our exploration of Saturn persists, it occasionally bestows upon us glimpses of hidden mysteries, reminding us of the vast unknowns that still shroud its intricate nature. Saturn, the solar system's second-largest planet, harbors a core approximately half its radius, boasting a mass 12 to 20 times that of Earth. Remarkably, if you had a reservoir large enough, Saturn would float in water. This is due to its astonishingly low density, just 0.687 grams per cubic centimeter, making it the least dense of all the planets in our cosmic neighborhood. But Saturn's uniqueness doesn't stop there. While most other planets orbiting the Sun appear nearly spherical, Saturn stands out as the flattest among them. It completes its orbital circuit in roughly 10.5 hours, spinning at a remarkable pace. This rapid rotation causes the gas giant to bulge at its equator while flattening at its poles, giving it a somewhat oblate shape. Saturn's grandeur extends far and wide, with a diameter at its equator spanning about 75,000 miles and a distance from one pole to the other, measuring around 68,000 miles. Its distinct golden and yellow bands visible from Earth owe their existence to the superfast winds in the upper atmosphere, whipping at an astonishing 1,100 miles per hour. The Cassini probe mission. The Cassini probe, named in honor of the renowned astronomer Cassini for his pivotal contributions to Saturn's understanding, embarked on a mission to unravel the peculiarities and enigmatic facets of the ringed planet. Crafted through a collaborative endeavor involving NASA, the European Space Agency, and the Italian Space Agency, this robotic spacecraft represented a culmination of human ingenuity. On the historic date of July 1, 2004, the Cassini probe achieved a milestone by becoming the fourth spacecraft to reach Saturn's vicinity. Unlike its predecessors that merely conducted flybys, Cassini broke new ground by daringly delving deep into Saturn's atmosphere, revealing a wealth of previously concealed mysteries. This intrepid explorer remained committed to its mission for an impressive 13 Earth years, diligently gathering a trove of invaluable data. Its prolonged stay would have continued for another decade or so, if not for the depletion of fuel reserves. Nonetheless, Cassini's triumphant journey was far from in vain. Before its final descent, the probe transmitted an astounding 453,000 images and an array of data from its diverse instruments, including spectrometers and magnetic sensors. This remarkable contribution profoundly enhanced our comprehension of Saturn's resplendent rings and dynamic atmosphere. Moreover, it beamed critical insights about Saturn's magnetic field back to Earth, enriching our knowledge of this colossal gas giant. One of the most captivating revelations from Cassini's mission was the discovery of Saturn's hexagon storm, a hexagonal pattern encircling the planet's north pole, a phenomenon that continues to captivate scientists and space enthusiasts alike. Saturn's hexagon storm. For nearly a century, the enigmatic hexagon storm has been a distinctive feature on the surface of the gas giant Saturn. This peculiar storm paints a visible pattern across the planet, easily discernible through telescopes and space probes. Its striking hexagonal shape spans an astonishing 20,000 miles in diameter, giving it its fitting name. At first glance, this hexagonal pattern might appear as a benign patch of clouds, but it conceals a tempestuous secret. Deep within its heart lies a colossal hurricane, dwarfing Earth's mightiest storms by a staggering 50-fold or more. This cosmic anomaly, where the hurricane and other vortices in the vicinity coalesce, forms an intricate hexagonal jet stream, perpetuating the mesmerizing pattern. What's equally intriguing is the composition of particles within this hexagon, which differs significantly from its surroundings. Inside, an abundance of tiny haze particles dominates, contrasting with the larger particles prevalent outside the hexagon's boundary. This disparity in particle sizes adds another layer of mystery to this already baffling phenomenon. Perhaps the most astonishing revelation is that the hexagon storm remains anchored in place, steadfastly tracking the planet's rotation. Unlike earthly weather systems that drift and evolve, Saturn's hexagon maintains its unwavering position. The hexagon storm, with its perplexing characteristics, has long puzzled scientists, pushing them to delve into its mysteries. Recent studies have added a new layer to this enigma, a gradual shift in its color. The once familiar blue hue is transforming into a captivating golden shade, a change that leaves scientists intrigued and wondering about its significance. Is this a novel event in the storm's history, or has it occurred before, an astronomical déjà vu? This extraordinary hexagon storm, which challenges our conventional understanding, has graced Saturn's expanse for decades, perhaps even centuries. The intriguing aspect is that our awareness of this phenomenon only commenced when astronomers finally acquired the means to observe Saturn up close. Could this storm, this mesmerizing hexagon, have existed in the deep cosmos, unbeknownst to us in eras past? If this captivating storm does indeed have roots in antiquity, dating back centuries or more, it might hold secrets far beyond our current comprehension. There might be stories written in their ever-changing colors, tales woven within their geometric form, which we may never fully fathom. Mysteries of Saturn's hexagon. In our quest for understanding, computer simulations step in to unravel the riddle of Saturn's hexagon. The key lies in the transfer of heat through the movement of fluids or gases within Saturn's atmosphere. This movement creates atmospheric flows, giving rise to vast polar cyclones and eastward-bound jet patterns. When these elements unite in Saturn's upper atmosphere, the result is the striking hexagonal shape that graces our view. Scientific models posit that Saturn's hexagonal storm endures because its genesis lies deep within the planet. However, this distinct storm is a singular phenomenon. Scientists have yet to encounter a similar one elsewhere in the vast expanse of the universe. This renders Saturn's hexagon an immense cosmic puzzle, captivating our imagination. Saturn, classified as a gas giant, owes its title to its predominant composition of hydrogen and helium. Yet there's a fascinating twist. The immense pressure and temperature deep within Saturn's atmosphere cause most of its hydrogen to transition into liquid metal. As one descends into Saturn's depths, the heat and pressure intensify, similar to the escalating geothermal experience as you delve into Earth's crust. Intriguingly, Saturn stands apart as the sole planet boasting a hexagonal storm, even among its fellow gas giants. Meanwhile, within Saturn's depths, a fascinating transformation takes place. Scientists speculate that the immense pressure can convert hydrogen into precious diamonds, gently raining down into the planet's core. This extraordinary process isn't just a gem-making show, it contributes to Saturn's intriguing thermal behavior. The friction generated by this transformative journey is thought to be a key player in the planet's unique heat emissions. Astonishingly, Saturn radiates double the heat it receives from the Sun, distinguishing it as a celestial anomaly, unlike any other in our solar neighborhood, Saturn's seasons. While scrutinizing the data beamed back by Voyager, scientists stumbled upon an eerie enigma, perplexing spokes streaking across Saturn's majestic rings. Yet, during the Cassini mission, a baffling twist unfolded. The ghostly spokes that once haunted Saturn's rings seemed to have vanished into thin air, deepening the mystery. Upon closer examination, a peculiar pattern emerged. These enigmatic streaks exhibited a dark demeanor when observed from above, but as if by cosmic magic they turned luminous when seen from below, akin to celestial chameleons. The root cause of these elusive streaks continues to elude researchers, but a tantalizing hypothesis emerges. These spokes may originate from dust particles within the rings, which emancipate themselves from icy chunks, floating freely above the icy boulders. Saturn's magnetic field likely plays the puppeteer in this cosmic theater. When the solar wind interacts with Saturn's magnetic aura, it sparks an electrically charged environment. This electric dance influences the behavior of charged dust particles, temporarily coaxing them to coalesce and create dense patches within the celestial rings. To add to the intrigue, Saturn boasts its quartet of seasons, each of which spans roughly 7 Earth years. Just as our planet experiences seasonal changes, Saturn dons its cosmic attire, setting the stage for these mysterious spokes to reappear during the planet's spring and fall. Now it's time for today's subscriber pick. In the dimly lit corridors of NASA's Jet Propulsion Laboratory, a sense of urgency and bewilderment hung heavy in the air. The news had just come in. Saturn, the majestic ringed giant of our solar system, was undergoing a baffling transformation. Scientists had been studying the gas giant for decades, but nothing could have prepared them for this. The once steady and predictable Saturn was now exhibiting unexplained fluctuations in its atmospheric composition. Methane levels were spiking unexpectedly, creating atmospheric disturbances never observed before. The iconic hexagonal storm at its north pole was rapidly changing shape and intensifying. The intricate dance of its rings seemed disrupted, with inexplicable gaps appearing and vanishing like cosmic mirages. Panic turned to determination as teams of astrophysicists, planetary scientists, and engineers worked tirelessly to unravel this celestial enigma. Telescopes were repositioned, and data poured in from probes and satellites tasked with monitoring the planet. Theories flew across the lab, but answers remained elusive. The world held its breath as headlines screamed, "Scientists are stumped, Saturn is changing, and it's not good." The implications of Saturn's transformation were far-reaching, sparking discussions on climate change, celestial mechanics, and the delicate balance of our solar system. In the face of this enigmatic metamorphosis, humanity rallied, driven by curiosity and a shared understanding that the mysteries of the universe were not to be feared, but to be solved, unveiling the secrets that lay hidden in the cosmos. What do you think might cause this depletion in Saturn? Please, do share your thoughts on this cryptic matter in the comments below. Saturn's magnetic field. Apart from Saturn's scorching temperatures, its magnetic field holds a captivating secret. A planet's magnetic field is more than just its north and south poles. It's like a cosmic storyteller, revealing details about the planet's day and year cycles. This magnetic tale is spun by the dynamo effect, a result of the planet's rotation stirring up the liquid metal within its core, generating powerful currents of energy that manifest as magnetic fields. In this magnetic symphony, Saturn plays a unique tune. Typically, a magnetic field's rotation corresponds to a planet's day cycle. Complete one rotation, and it marks one day. However, Saturn defies this celestial choreography. Its magnetic field stands at an angle that challenges conventional wisdom. It shouldn't persist in its current strength and orientation. Astonishingly, Saturn's magnetic field is a whopping 580 times mightier than Earth's, an enigma that leaves scientists in awe, wondering at its origins and longevity. The mystery deepens as scientists grapple with understanding Saturn's day cycle. Deciphering how long it takes for Saturn to complete one rotation, a day in its magnetic ballet, demands meticulous study. Beyond Saturn's magnetic fields, scientists delved into the mysteries of its radio waves. They made a remarkable discovery. Saturn emitted radio waves that oscillated in strength, rising and falling in a rhythmic dance. This pulsating pattern wasn't random, it adhered to a unique timing. Researchers observed that higher levels of radiation surged every 11 hours. This intriguing revelation neatly matched the estimate derived from Voyager 2's data. The Voyager probe, in its exploratory mission, had clocked Saturn's day cycle at 10 hours and 40 minutes. Intriguingly, this newfound 11-hour day became the official standard. But as Cassini, the diligent observer, meticulously tracked Saturn over its 13-year mission, it stumbled upon an enigma. Cassini found that Saturn's rotation speed was far from constant. It exhibited unpredictable variations, with the time it took to complete one day sporadically expanding and contracting. This peculiar phenomenon baffled the scientific community, causing a divide in beliefs. Some experts steadfastly refused to accept that Saturn's behavior could be so erratic naturally. Instead, they embarked on an in-depth investigation to uncover the root cause of these fluctuations. Their hypothesis centered on something within Saturn's complex atmosphere being the driving force behind this puzzling phenomenon. However, conclusive evidence remained elusive, and the debate raged on. Were these experts correct in their assumption, or was Saturn hiding an even deeper secret? At present, the available data can't definitively confirm or refute their theory. Nevertheless, it's essential to note that these deviations were relatively minor, hovering around a mere plus or minus 1%. In essence, the 11-hour day assumption still largely held its ground, even as Saturn continued to perplex astronomers with its intricacies shrouded in mystery. The Cassini probe, in its mission of unraveling Saturn's mysteries, made fascinating revelations. Firstly, Saturn's heat didn't conform to the norm. It was far from the ideal heat source. Additionally, Saturn's auroras were a captivating enigma. Unlike Earth's auroras, which depend on solar flares, Saturn's auroras displayed an independent flare. They danced in the sky, undeterred by solar winds. The source of Saturn's auroras was equally extraordinary. They sprang to life due to electrically charged particles emanating not from the sun, but from Saturn's rings and moons. This phenomenon was an anomaly in our solar system. Intriguingly, scientists speculated that these charged particles might play a role in Saturn's extreme temperatures, adding to the planet's mystique. Speaking of Saturn's rings, they held a superlative title. They were the grandest in our solar system, a celestial jewelry box. These 7 magnificent rings were thoughtfully named in order of their discovery: the B ring, the C ring, followed by the D, E, F, and G rings. Each one is proof of Saturn's celestial splendor. Saturn's rings. While other giants in our solar system boast rings of their own, Saturn's rings are the true showstoppers, particularly the Uranian rings. These celestial wonders earned their names in the order they were discovered and are gracefully positioned along Saturn's equator. Imagine this: the rings commence their journey about 4,300 miles from Saturn's core, extending outward for an astonishing distance. Take the E-ring, for instance. It spans an incredible range from approximately 75,000 miles to 260,000 miles. To put this into perspective, envision a road that stretches across the entire length of Saturn's E-ring, from its outer wisps to the inner boundary. If you were to maintain a constant speed of 100 miles per hour, it would take over 2.5 months to traverse from one end to the other. Now, let's not forget about the Phoebe ring, which adds to Saturn's celestial charm. This ring sprawls approximately 100 to 270 times the radius of Saturn itself, echoing the planet's distinctive shape. Saturn's rings are an astonishing sight, known for their remarkable flatness. In-depth examinations have revealed that within specific regions, these rings can puff up to about 0.6 miles in thickness. However, the main attraction lies in their mind-boggling slimness, with the primary rings measuring a mere 32 feet in thickness. What adds to the intrigue is the diversity among Saturn's ring particles. It's like a cosmic smorgasbord, ranging from tiny icy grains resembling specks of dust to substantial fragments akin to the size of houses. And here's the kicker: there are even a few extraordinary particles that defy the norm, soaring to dimensions that rival mountains. Formation of Saturn's rings. Today, we may believe we've unraveled most of the secrets of Saturn's magnificent rings, but this cosmic marvel keeps defying our expectations. Within these rings, composed primarily of water ice, an intricate dance unfolds. It's a delicate balance between two opposing forces. Saturn's immense gravitational pull tugs the particles towards the planet, while their orbital velocity pushes them outward into the vast expanse of space. One of the most profound mysteries is the origin of these rings. For over 90% of Saturn's existence, it didn't possess this distinctive feature. So when and how did they form? One theory proposes that the rings emerged later in the planet's history, the result of collisions between small icy moons that orbited Saturn. These impacts might have been triggered by the gravitational influences of passing asteroids or comets. Interestingly, a 2016 study put forth another captivating notion. It suggests that Saturn's rings could be the remnants of dwarf planets that met their fate in the distant past. These enigmatic rings could be the legacy of these celestial bodies, now encircling Saturn in their ghostly splendor. Alternatively, it might have been a colossal collision that gave birth to these rings. There's speculation about a potential moon called Chrysalis, which may have existed before Saturn's rings formed. Computer simulations indicate that Chrysalis, similar in size to Saturn's third-largest moon, Iapetus, could have been the catalyst. In addition, the ever-shifting angles at which we observe Saturn's rings might be a consequence of its gravitational interactions with Neptune. These interactions caused Saturn's axis to tilt and wobble in synchronization with Neptune's orbit, adding another layer of complexity to this cosmic spectacle. Meanwhile, the cosmic ballet between Saturn's moon Titan and the ill-fated Chrysalis is a mesmerizing tale. While Titan engages in a rapid gravitational dance, distancing itself from Saturn, our own moon follows suit but at a more leisurely pace. Around 100 to 200 million years ago, a celestial symphony unfolded. Titan and Chrysalis entered a resonance, and as Titan waltzed outward, its gravitational influence played the role of a cosmic disruptor. Chrysalis, once in a stable orbit, found its trajectory destabilized. It bravely ventured closer to Saturn, succumbing to the mighty gas giant's gravitational embrace. In a dramatic finale, nearly 99% of Chrysalis met its fate, merging with Saturn's colossal bulk. But the indomitable 1% endured, leaving behind the awe-inspiring ring system that graces Saturn's celestial expanse today. Depletion of Saturn's rings. In a recent study, scientists have unveiled the remarkable story of Saturn's rings. These celestial jewels have a relatively youthful age, estimated at approximately 100 to 400 million years. However, their future is not one of eternal splendor. They are destined to fade into history. A celestial marvel in the form of the sun plays a pivotal role in this narrative. In another 100 million years or so, Saturn's majestic rings will succumb to the Sun's influence. The Sun's relentless radiation and occasional plasma clouds, generated by space rock impacts, conspire to melt away Saturn's iconic rings. The drama intensifies as Saturn's rings sometimes undergo electrifying transformations. Dust particles within them become electrically charged and perturbed. When this occurs, these particles attach themselves to Saturn's magnetic field, which inexorably draws them inward, towards the gas giant's upper atmosphere. Adding to the intrigue, Saturn and its rings perform a cosmic ballet around the Sun, tilting as they go. This tilting alters the amount of radiation received by the inner ring layers, influencing the intensity of the icy ring rain. NASA's findings reveal a stunning reality. Saturn's ring system is vanishing at an astonishing pace. Every half hour, it loses an Olympic swimming pool's worth of water. Recently, after 4 decades of relentless research, scientists have unveiled the spectacle of ring rain cascading onto Saturn. A continuous deluge, around 6,000 pounds of icy particles, previously bathed in solar ultraviolet radiation, gracefully descends onto the planet. As these particles embark on their atmospheric journey, they transfer their accumulated energy to the surroundings through collisions with other particles. This dynamic exchange contributes to Saturn's atmospheric heating and might even give rise to the luminous bands that grace the planet's northern and southern hemispheres. Saturn's rain isn't limited to its stunning rings. There's another celestial spectacle moon rain. Enceladus, one of Saturn's moons, showcases a mesmerizing phenomenon. It expels jets of water ice into space from its subterranean ocean. These tiny ice particles embark on a cosmic journey, influenced by both Saturn's magnetic field and gravitational forces. Their destination? Saturn's colossal atmosphere contributes to the moon rain phenomenon. But what's in this celestial cocktail? Saturn's ring rain is a complex mix of chemicals, including organic compounds. It comprises water, along with butane, propane, methane, ammonia, carbon monoxide, carbon dioxide, and molecular nitrogen. This intriguing blend holds the potential to alter the composition of Saturn's atmosphere in the future, impacting oxygen and carbon levels. While these changes aren't enough to support life on Saturn itself, the real intrigue lies with Saturn's moons. Enceladus, with its subsurface ocean and intriguing emissions, sparks the imagination of scientists exploring the possibility of life beyond Earth in the far reaches of our solar system. The Saturn's moons. Recently, Saturn once again asserted its reign as the undisputed king of moons in our solar system. A remarkable discovery unveiled 62 new satellites gracefully orbiting the ringed giant, bringing the total count to a staggering 145 moons. Yet it's 2 of Saturn's moons, Titan and Enceladus, that truly captivate the scientific community. Titan stands out with its thick atmosphere, resembling a planet more than a moon. Within this atmosphere lie abundant organic molecules, including complex hydrocarbons. These hydrocarbons serve as potential building blocks for life, sparking curiosity about the possibility of life forms evolving on this enigmatic moon. On the other hand, Enceladus holds a different allure. Deep beneath its icy surface, it harbors a subsurface ocean of liquid water. This hidden ocean positions Enceladus as a promising candidate for hosting life, or at least creating conditions conducive to its existence. Titan's uniqueness extends further, with rivers, lakes, and seas gracing its surface. However, these aren't Earth-like bodies of water. Instead, they're liquid reservoirs of methane and ethane, compounds associated with the metabolic processes of many organisms, offering a potential source of energy. While it's unlikely that life as we know it, with lipid-based membranes and all, could thrive in Titan's frigid conditions, scientists have pondered an alternative possibility involving a molecule called acrylonitrile. Acrylonitrile, a remarkable molecule, possesses the potential to form stable and flexible structures similar to cell membranes. These structures take the shape of thin, sheet-like materials that could further mold into tiny hollow spheres known as exosomes. Much like the lipid bilayers found in familiar cell membranes, these exosomes could serve as minuscule containers for storing and transporting vital substances. What adds to the intrigue is the significant presence of acrylonitrile in Titan's atmosphere, detected by the ALMA observatory. There are up to 2.8 parts per billion of these molecules swirling within Titan's air. Scientists speculate that this chemical bounty might find its way down to the Moon's surface over time. Calculations reveal that Ligia Mare, one of Titan's expansive lakes, could have collected enough acrylonitrile to form around 10 million exosomes in every milliliter of its liquid. To put this into perspective, this surpasses the abundance of approximately 1 million bacteria per milliliter of coastal ocean water on Earth. Excitement builds as NASA prepares to launch its Dragonfly drone in 2027. This innovative mission aims to delve deep into the mysteries of Titan, shedding light on the potential for life to emerge on this celestial body. As we await the findings, it's worth noting that our solar system continues to surprise us with possible candidates for extraterrestrial life, tantalizing us with the prospect of new cosmic discoveries. Are you convinced that by 2027, NASA could finally decipher this ambiguous planet's dilemma? Do share your thoughts in the comments section below.